Here's the second half of the review for Chapter 6, starting with the absolute value. Solve the absolute value inequalities. Remember, there'll be two solutions. Two solutions means that I'll have to eventually split my one inequality into two inequalities. So where does that begin? Notice these bars are not parentheses, so I'm not going to distribute the 4. They're absolute value bars because they're straight up and down. I have a 4 and a 3 outside of my absolute value bars. Before I can divide, I have to subtract. The opposite of plus 3 is minus 3, so I subtract from both sides of the inequality. 3 minus 3 cancel out to make 0, and 15 minus 3 becomes 12. I bring down my greater than or equal to sign. On this side, I bring down the 4, the absolute value of x minus 6. Because the 4 still lies outside of my absolute value, and it's being multiplied, I have to use division with this division bar here to divide and cancel out the 4. On the other side, when I divide by 4, the result is 3. Now that everything outside of the absolute value bars have been taken care of, I can split my inequality into two inequalities. X minus 6 greater than or equal to 3, and x minus 6 less than or equal to negative 3. Notice the first one looks just like the original without the absolute value bars. And the second looks very close to the original, but when I change the 3 to become a negative 3, I also have to change my greater than or equal to sign to a less than or equal to sign. In order to solve for x, because remember I'm solving for the inequality, in this case the variable x, I have to add 6 to both sides of my inequality. The opposite of minus 6 is plus 6. 3 plus 6 makes 9. So I have x greater than or equal to 9. The question is it and or or? Will I shade inward or outward? Well, I can answer that by finishing my solving. Again, I add 6 to both sides. Negative 6 plus 6 cancel out and leave me x. Negative 3 and positive 6 makes positive 3 because 6 minus 3 is 3. If I follow the inequality signs, notice this x less than or equal to 3 is a closed circle shaded to the left, left for less than. This inequality, x greater than or equal to 9, closed circle at 9, greater than goes to the right. They're shading outward. So x is greater than or equal to 9, or it's less than or equal to 3. If the original inequality is greater than or equal to, we shade outward if I was asked to graph. If it's less than or equal to, it'd be considered an and statement where I'd shade inward. Just remember when you take the test, there'll be two solutions. Sometimes it'll be a matter of 9 and negative 9. Sometimes it won't. Notice we ended up with 9 and a positive 3. Don't always assume you'll get a positive and a negative. The next example that goes along with question number 6 is which ordered pair or pairs is a solution to the inequality. In this example, y is less than or equal to x plus 1. I'm asked to test 2 points, 1, 0, and 3, 2. Remember, points are given an ordered pair of x and y. We're asked which of these solution points makes the inequality true. Is it a yes or a no? Solution or not a solution? The first one, I'm going to substitute 1 in for x and 0 in for y. So I ask myself, is 0 less than or equal to 1 plus 1? When I simplify and find the sum of 1 plus 1, I get 2. So is 0 less than or equal to 2? Sure it is. It's a true solution. I plug in the next point. 3, 2. 2 goes in for my y, 3 goes in for my x, and I find the sum of 3 and 1. Is 2 less than or equal to 4? Yes, it is. A positive 2 is less than a positive 4. So that's also a solution point. It's your turn to try question 6 on your own. The next example that goes along with question 7 on the review asks you to sketch a graph of the inequality. This time we have an x and a y variable, so we're going to have to use the coordinate plane. There are 3 methods that we covered in chapter 4. Those 3 methods involved using a table of values. Sometimes you're given the value of x and you have to find y. Sometimes you have to choose your values for x and find y. The second method we used was slope-intercept method. This is where we solve for y and put it in y equals mx plus b form, plotting the y-intercept and using the slope to find the next point. In method 3, we knew it as the cover-up method. This is where we found the x and y-intercept, also known as the cover-up method, because we had to cover the y to find the x-intercept and cover the x to find the y-intercept. So, if I chose to use method 3, I'd be solving for the x-intercept, covering up the y, and have an inequality of negative 1x less than or equal to 4. To get rid of the negative 1, I'd have to divide both sides by negative 1. I'd get x greater than or equal to negative 4, since the inequality changes directions when I divide by a negative. The same is true for the y-intercept. I also have an inequality. When I'm looking for y, I have to cover the x. I have negative 1y less than or equal to 4. Again, to get rid of the negative 1 that's being multiplied to y, I have to divide both sides by negative 1. So y will be greater than or equal to negative 4. I then plot my 2 points. The x-intercept will go on the x-axis, which goes right to left. Since it's a negative 4, I go left 4 places. Since the y-intercept is also negative 4, and the y-axis goes up and down, I'd go down 4 places. Then I have to determine if I have a solid line or a dashed line. Since I have a less than or equal to, the equal to tells me it's a solid line. If I chose to use a different method, such as slope-intercept method, I would simply solve for y. In order to solve for y, I have to add x to both sides because I need to isolate the y. Opposite of minus 1x is positive 1x. I'll bring down my negative 1y after I've canceled out the negative 1x with the positive 1x. On the other side, I bring down the 1x and a plus 4 because the 4 was positive. To get rid of the negative 1, I'm dividing everything by negative 1. Negative 1 divided by 1 leaves me with y. The less than or equal to sign becomes a greater than or equal to sign. The slope, positive 1 divided by negative 1, becomes negative 1. The y-intercept, positive 4 divided by negative 1, becomes negative 4. Just remember, in slope-intercept form, y equals mx plus b, you begin with b. So 0, negative 4, begins, you guessed it, down 4. From where, you ask? Begin at the origin and go down 4 spaces. Plot your y-intercept carefully. Use the slope of negative 1 over 1. Remember, slope is either rising or falling. In our case, because it's negative 1, it's falling 1. And to make a slope of negative 1 a fraction or a ratio, rise over run, we write it over 1. So I go down 1 and over 1. Notice I repeated the pattern several times on my graph. The more points I have, the more accurate I can draw my line. Now I have to decide, is it solid or dashed? Like I said, if greater than or equal to, it's a solid line. If you're not sure, make yourself a key like I did above. Less than, greater than, and not equal to are dashed lines. Less than or equal to, greater than or equal to, and equal to are all solid lines. So I'm going to make sure that I draw a solid line. Let me just get that line tool going. Whoa, check that baby out. Oops, not quite right. Let me just make a few adjustments. Oops, kind of missed the line there, didn't I? There we go. Before I'm done, I have to make sure I test 0, 0, or test any point not located on the line. I choose to test 0, 0 because it happens to be one of the easiest points to test, since 0 will cancel out the x and y and make them 0. I ask myself, is 0 less than or equal to 4? Is 0 less than or equal to a positive 4? Is 0 less than or equal to positive 4? Is it to the left of the number line? It sure is. If you're not sure, though, you can always try a point somewheres on the other side of the line. Don't pick one too difficult. If I chose, for example, negative 6, negative 5 in quadrant 3, quadrant 3 because it's to the left and down from the origin, I would substitute it into my inequality. Notice negative 1 times x, in my case, is negative 1 times negative 6. And negative 1 times y is negative 1 times negative 5. We know that two negatives make a positive. So 6 plus 5 is less than or equal to 4. Is that true? Is 11 less than or equal to 4? Not on this planet. Since I've proven that this side doesn't work, I've just confirmed that this side does work as a solution. And I'm going to continue to shade it in.